We're going to work with in chapter 9 is we're going to, in lesson 9.1, we deal with geometric sequences. Now we've already worked with arithmetic sequences, and those were actually back when we worked with linear functions, okay? In an arithmetic sequence, does anybody remember what happens in an arithmetic sequence? So in other words, remember, we're not supposed to forget the things we've learned before. Okay, so you have a sequence, first of all, is what? What is a sequence? A list of what? Numbers. It's just a list of numbers. And in that list of numbers, when there's a sequence, determining what kind of sequence it is, we look at what's going on for a pattern in it. So does anybody remember the pattern? What happened in an arithmetic sequence that made it linear?
Isn't it like the first number times 2?
Now that would be, in an arithmetic sequence, we don't multiply, but they all either, you add something. They go up by the same number or they go down by the same number. So anybody think they give me an example of an arithmetic sequence?
2, 4, 6, 8, 10.
Yeah. The even numbers, if you start at 2, doesn't, because the even numbers we don't know where they start, because did you know negative numbers can also be even?
Yeah.
So there's an infinite number of even numbers. So if we started our even number sequence at 2, the next number would be 4, the next number would be 6, because we just keep adding 2, okay? Or it can go down, it doesn't have to grow. An arithmetic sequence does not have to grow, it can also get smaller. So give me an example of an arithmetic sequence that's getting smaller as it goes on, rather than larger.
-2, -4, -6.
Okay, so start at -2, subtract 2, the next term would be -4, subtract 2, the next term would be -6, and so on. Okay, Matt?
Wouldn't odd numbers be a sequence?
Yeah, odd numbers would make up one also. You could start with any odd number and just list all of the odd numbers going on from there, because odd numbers also just go up by 2s, don't they? Yeah. So when we have something where we can talk about adding or subtracting the same thing, then we have an arithmetic sequence. In a geometric sequence, the kind we're going to study now, each term is multiplied. I want you to circle that here. Let's underline geometric sequence. Each term is multiplied. Now we're not adding the same thing, we are multiplying by something. And that something could be an integer or it could be a fraction. It doesn't have to necessarily be a nice integer value, but we have to keep multiplying by the same thing to get the next terms. So, and that number, this is a really important thing, is called the common ratio. So, in an arithmetic sequence, we call it a common difference. In a geometric sequence, we call it a common ratio. So when they ask you for the common ratio, they're actually asking you for that multiplier. What do you have to multiply by to get the next term? Okay? So we have this first one here, determine if the sequence 2, 6, 18, 54 is a geometric sequence. Well, how can you just, if you look at it and you're like, well, I can't tell what you multiplied by, how could you figure out what the multiplier is without
Divide the first number by the second number.
Or vice versa?
Or, yeah.
You just do a division problem. You take the second term divided by the first term, and that's what they did here. They took, well, they actually started at the end of it. So here's the first term being divided by the second term, and the common ratio, the ratio came out to 3. Then they took the 18 and divided it by the 6, and they got 3 again. Then they took the 54 and divided it by the 18 and also got 3. I like to start at the beginning of it. They started at the end of it. So they said this is a geometric sequence, and 3 would be considered the common ratio.
But you have to do it 3 times.
So, yeah, because it can break down actually. Sometimes it can work for the first 2 and then not work for the third one. So yeah, you do have to show that it works. You get the same ratio every time. So then the next one, 5, 10, 15, 20. Is that a geometric sequence?
No.
Because notice what happened. The ratio was 4/3, 3/2, and 2.
They kept divided by 5.
That's not a common ratio. What kind of a sequence is that?
That's a I can't say it.
Arithmetic.
There you go.
That's an arithmetic sequence because what's happening?
It keeps adding.
It keeps adding 5, doesn't it? So that one's actually an arithmetic sequence, not a geometric sequence. Okay, so we're going to determine if each sequence is for these 1 through 4, Determine if each sequence is a geometric sequence, and notice it says show support.
I already think
So what would be our step of work that we could start with for number 1?
divide 4 by, or 8 by 4.
Okay, and
4 by 8. Yeah.
4 by 8, yeah. So you guys, it might make more sense if you do start at the end. Do you like starting at the end of it instead? So we would say 4 divided by 8. And we don't need to divide that out. Let's just, what simplified fraction is that?
1/2.
1/2. Okay, so there's one of our ratios. Now what would be our next
8 over 16.
8 over 16? 8 divided by its previous term, which is, that also simplifies to 1/2. And remember, we have to check the next one also because it can break down. Matt?
Oh, I did it the other way. The given 32 over 16.
Yeah, that's what I did.
Oh, you can't do it. You can't divide that way though.
Well, isn't
Okay.
that what they did up top?
No. Look up top and study again. Because are you getting 1/2 or are you getting 2?
2.
You're getting 2. Is that the same thing? Okay, so here's what should happen. Once you get, which is it's a good thing that you're bringing this up, Matt, because here's what should happen. When you look at this first term and you multiply it by the common ratio, it better get you the next term. So is 32 times 2 16? No. Is 32 times 1/2 16? Yeah. So whatever you end up with has to make sense to the sequence. If you guys say the common ratio is 2, the sequence would be getting bigger as it went along. Is it getting bigger?
Okay, but if you go from the, I really saying, so if you go from the back, and then before integral times 2 would work, because 4 times 2.
Yeah, but we gotta work from left to right.
Right, yeah.
Yeah, we have to work from left to right in this sequence, just like we were when we were talking about arithmetic sequences, okay? So when you get your common ratio, you have to make sure it makes sense. If you get a number greater than 1, that means your sequence better be doing what? Going down?
Up.
If you're multiplying by a number greater than 1, it should be getting larger, shouldn't it, as it goes along? If you're multiplying by a number less than 1, somewhere between 0 and 1, what should be happening? It should be getting smaller. And then that's just talking about when we are talking about all positives. Okay? So 1/2, and so then it says, determine if the geometric sequence if it is a geometric sequence, and we're going to say yes, it is, because we got 1/2 all 3 times.
So should we say 1/2 is the common ratio?
Yeah, I can't remember how this likes to, yeah, that's what we're supposed to say. So yes, 1/2 is, I didn't know if there was an abbreviation for it, there's not, is the common ratio. In other words, if they asked us to do some more with this sequence, that would be a really important piece of information. Okay. Number 2, let's check that one out, see if it's a geometric sequence. Or in other words, can we always multiply by the same thing to get the next term? So what should we show for support?
32 over negative 30. Well, negative 16. I can't talk to it.
Take a term, divide it by its previous term. That's how you do it. That's what your thought has to be. Take a term, divide it by its previous term.
No, I'm lost because
Okay, look at here, Matt, look at what we did over here. 4
yeah.
divided by its previous term. 4 divided by its previous term. We're doing the same thing here.
Okay.
32 divided by its previous term.
Okay.
Okay, what is 32 divided by negative 16?
Negative 2.
Negative 2. Okay, what's our next one going to be?
Negative 16 over 8.
Negative 16 over 8. And what does that become? Negative 2. So we're finding all of our ratios, and we want to make sure that they all are going to come out to the same thing. 8 divided by negative 4, negative 2. So do we have a geometric sequence?
Yes.
Yes. And the common ratio is?
Negative 2.
Negative 2 is the common ratio.
So we always start from the back then?
Well, you don't necessarily have to start from the back. You could have started here at the front, but when you start at the front, you got to go to the second term Start with the second term and divide it by its previous.
That's what you can't do.
So whichever one makes more sense to you, I would move from that direction, okay? Now, does it make sense? What you could always do is just stop right here and say, okay, if I took 32 times -2, I would get what? What would happen? 32 times -2 to get the next term, what would we get?
-64.
-64. Does that seem reasonable? Yeah. Notice what's happening. Every other one is negative.
Yeah.
Every other one is positive. We need the next one to be negative, and we also need its absolute value to be bigger, don't we? So I think we have a good common ratio. Okay, any other questions before we move on? Okay, how about our next one?
I already can tell you no.
So what are we going to do?
It's 8/9 or 8/6.
Just leave these as fractions, you guys, if nothing else. If they don't divide out nicely, especially.
It's 4
So
thirds.
it's 4/3. There's that one.
And then 6/4.
6/4.
And that's 3/2.
That's 3/2.
So it already doesn't work.
No, it doesn't work. We can stop. Because 4/3 and 3/2, are they the same?
No.
No, they're not the same value. If it was another name for it, then we could say, well, maybe we got to keep going, but we would say no to this one because we didn't get a common ratio. We don't have a common multiplier, I call them. Okay, what kind of support should we start with for the next one?
0.4 over 2.
0.4 divided by 2.
That's 1/5.
No, it's not 0.2.
Is 0.2 1/5, Cassidy?
Oh, yeah.
It is, isn't it? Yeah. So Brian's okay. Okay, what would be the next one?
2/10.
2/10. Again, Brian said this was equal to 1/5. Do we agree? Yeah. And is this equal to 1/5? 2/10? Yeah. Okay. So we got 1/5. We got 1/5 again. But again, remember we could break down and not be, so we have to check all of them. So what's our other one we have to do?
10/15.
10 divided by 50, or 10/50, and that becomes 0.2 or 1/5. There's 5 10s and 50s, so 1/5 also. So is this a geometric sequence? And yes. And you could either way, you could say it as 0.2 or 1/5. It does not matter which name you give it. 1/5 is the common ratio.
For the next 3 terms.
Okay. So we're multiplying by a number between 0 and 1, which should make it keep getting smaller. Is that what we want? Is our sequence getting smaller? Is that what's happening? Yeah, it's getting smaller. Multiplying by something between 0 and 1 should make it keep getting smaller. So we probably have a good common ratio. Okay, let's go to the back side now. Now on this one, they're saying find the next 3 terms in the geometric sequence. So first thing we do is find the common ratio. Now, you know what? I'm going to let you off the hook for something, but you do have to show me. This other part of work. Okay, so those of you who are jumping ahead, stay with me here so that I can stamp your assignments around. Okay? If they tell you, they say find the next 3 terms in the geometric sequence, they're already telling you it's geometric, aren't they? So that means you should be able to take any term you want, except the first one. You should be able to take any term in that sequence and divide it by the previous one, and you'll have a common ratio, right?
So we don't.
So you don't have to show all 3 of them like they did here. I'm not going to make you show all 3 of them. You can just show one of them.
Can I show them?
You absolutely.
Okay.
Now, here's what else you have to show, though. Now, you have to show the multiplying. If you're going to use your calculators, that's fine. But show what's going into your calculators first. So in other words, write it all out first, and then let your fingers do the walking on your calculator and get the answers, okay? So let's practice together here. Number 5. Find the common ratio in each geometric sequence. In other words, they're telling us it already is. So we can pick any of those terms except the first one and divide by the previous term to get our common ratio. So which ones do you want to use? Pick for me.
What?
I'm trying to find the common ratio.
1 and 5.
So how would I set it up?
5 over 1.
Yeah, I have to take a term and divide it by the previous one. So I right now know that my R value is, my common ratio value is 5. And actually, by the way, I think they do call that an R sometimes, but.
Can I show it on the board?
And then we're going to show getting the next 3 terms of that geometric sequence. I'd prefer you not. How about we do this, okay? So now we're going to, we take the last term of the sequence, and we do what with that? Multiply it by 5, and say that that equals 625. And instead of doing a run-on problem, we're going to go like this. I'm already letting you out of some of the work, aren't I? Right? I didn't make you do the 3 divisions. 625 times 5, what's that? 3,125?
Yeah.
Okay. 3,125 times 5.
15,625.
Okay. 15,625.
So we have to show that?
Yeah. And there's our next 3 terms. We're not going to make it a run-on problem, no. We're not going to do 125 times 5 equals 625 times 5. We just keep, you know, it's like a run-on sentence in English. They don't let you do that there either, do they? No. No. So, okay. Okay, so that is how much work you need to show. That's the minimum, right there. If you want to do more, you do more, but that's the minimum. Okay, let's do the next one. Breland, you picked the 2 terms we're going to use to find the constant ratio.
12 over -6.
Okay, 12 over -6. So our common ratio is -2. So we need the next 3 terms, so we start with the last one and start multiplying. And again, you can use your calculators, but let's write it down before you do. What's 48 times -2?
-69.
No, -96.
The 96, yeah, I said it backwards.
Okay, -96. And then we have -96, so it's going to get multiplied by -2.
192.
192. And now we'll take our 192 and multiply by -2. And what do we get?
-384.
-384. And then we look at our results and we say, does it seem reasonable that those are what I got? Let's look at what was going on. We have a negative, positive, negative, positive, negative, positive, negative. Feeling good about that? Without the negative signs, it's growing. Ours is growing.
Yes.
Yeah, see, without the negative sign, the absolute value, their distances, yes, those are growing. So again, we should always stop, take the time, and make sense of your answers. Do they make sense? This is one of those times we can. Maybe when you were using the quadratic formula to solve quadratic equations, you couldn't maybe quite get your head wrapped around, I don't know if this answer makes sense or not. But we're back to something where we can say, does this answer make sense? Okay. Garcia, will you give me the setup that's going to get us the common ratio for number 7? Which one do you want to use?
13.5 divided by 9.
Okay. 13.5 divided by 9. What's that equal?
4.5.
Okay, 1.5. And because it's a nice decimal, I'll let you use it as a decimal. If it wasn't a nice decimal, we wouldn't use it. We would have to go with a fraction. Okay, so now we will take 13.5 and multiply it by 1.5. And what do we get?
20.25.
Sorry, what?
20.25.
20.25. And now we do 20.25. times 1.5. And Jossie, what do we get?
I will tell you. You get, wait, okay, you get 30.375. Do we have to do all three of those, or can we
Yeah.
round on that?
No, these we want exact answers. They weren't doing any rounding that we're aware of, and so once they tell us to round, we don't. Okay, and then now we're gonna take the 30.375 and multiply that times 1.5, and even a longer decimal yet. Haley, what do we get for that?
45.5625.
There are our next three terms. Everybody agree? Yeah. You calculators got the same answer? Okay. So no, even though the decimals are long, we're gonna keep them unless it says to do any rounding. Okay. What should we use? Should we use 1/2 divided by 1/4? No. No, let's make our lives a little bit easier. What should we use, Brian?
What now, sorry?
Pardon?
I was working on this.
No, we're gonna wait for you. Which one should we use? The number 8, we're looking for the constant ratio. What do
I'd
you guys-
probably do 2 over 1.
I think that's a pretty good choice. 2/1, not gonna have to work very hard. The common ratio is 2. Okay, so our common ratio is 2. Now we can go to work finding the next three terms. 2 times 2, our last term times the common ratio, 4. 4 times 2, 8. 8 times 2, 16. And I like our answers because it's growing. They're all positive, like they were in the sequence. Okay. Any questions, concerns? Anybody unclear what I'm going to expect to see for work tomorrow, and I'm going to be very, maybe you'll consider it crabby about it if you don't show it. Okay.